I think it's really important that you understand the technology as the CEO. It's really important that you don't view it as two silos and really treat it as a collaboration. The main thing was I've always been fascinated in science and engineering and the ability of science and engineering to improve human lives. So I think the two problems really facing eFuels today are energy intensity and...
Hey everyone, quick note for you. You're currently listening to the free preview of this episode. If you'd like the full thing, the full shebang, go over to our Substack. That's cleantechies.substack.com/subscribe and become a paid subscriber. Any paid subscription gets you full access to the show on the Clean Techies Substack. Hey everyone, welcome back to the Clean Techies podcast, the #1 podcast for climate tech entrepreneurs. I'm Silas Maynor and I will be your host today. Even as, everybody's going undercover and changing their branding in climate tech, we will be here each week delivering valuable insights and lessons from other founders and investors in the space. So be sure to stick around even as the vibe shift continues. All right, if you're not already, do us a favor and subscribe on our YouTube channel, especially if you're one of our many free subscribers. You're getting a lot of value week after week, but you have not yet made that leap to become a paid sub. So show us some love by giving us a subscribe on the YouTube. It'll really help us increase our reach there. Okay, today we are talking about eFuels with Joe Rodden, the CEO and co-founder of Lydian. Their URL is lydianlabs.com, not to be confused by Lydian Labs, which is a totally different company. So this is Lydian. They have an eFuels technology that takes in CO2 or air and water and then uses electricity to output aviation fuels. That's kind of the very simple version of it. You should know they went from initial tech discovery to pilot in just over 3 years. So if you want to know how, you're going to have to listen. There is a dump truck load of value in this episode, especially for any deep tech founders. So let's dig in. All right, welcome to the show, Joe. How are you doing today?
Good, Silas. Thank you again for having me. It's great to be here.
No, absolutely. It's our pleasure to have you on. I'm at least a big fan of Lydian. I've known about you guys for a little while. I don't know if Somil is or not, but I'm excited to have this. So let's start off. I guess give us just a really brief intro of who you are and what you're working on, and then we'll go from there.
Yeah, absolutely. So I'm the co-founder and CEO of Lydian. We have been, my co-founder and I, working on the company for about 3.5 years now. And we are a sustainable aviation fuel company working on a power to liquids pathway to produce eFuels or eSAF at radically lower cost than alternatives. Yeah, so that's a little about us. My background is more on the finance and business development side. My co-founder is a chemical engineer by training, so you can kind of marry those two parts of the business.
Yeah, it's obvious you guys have a little bit of the dynamic duo there because you mentioned in your very first pitch that we do it radically cheaper than other people, right? Otherwise, we might be looking at a different situation in 5 years. But give us, who is one like clean tech or clean techie OG that you would love to have dinner with and why? Living or dead, by the way?
Okay, I think Steve Chu would be an amazing one. Former Secretary of Energy in the mid 2000s during the so-called Clean Tech 1.0. He's a literal Nobel Prize winner in physics, so a brilliant guy, and oversaw DOE at a time during an early kind of boom in clean tech where we got so many things right, but also a lot of things kind of very wrong. And I think in hindsight, it's easy to look back at things like Solyndra and the other failures of Clean Tech 1.0. And I would just love to get Dr. Chu's perspective, Secretary Chu's perspective on what his viewpoint is in hindsight on some of those early failures and what we might be getting wrong again today and what he's learned from everything that he saw over the years.
Okay, amazing. Were you, I guess, out of curiosity, what were you doing during Clean Tech 1.0?
I was in high school during Clean Tech 1.0. It wasn't doing much thinking about energy at the time, although my parents were both working in oil and gas for most of my early childhood. So I had some connection to the energy industry, but mostly I've been a student of that period of history in the years since after getting into the climate and energy space.
No, I love to see it when people are students of the past because it helps you avoid mistakes in the present, right? This is often something we see with any founders that end up folding in, right? Like they weren't, if we look in hindsight with their conversations, and they weren't as studious of those items. So I guess one thing I was curious after understanding a bit about your background is how do you go from being in finance at BlackRock to starting an eFuels company? Give us the journey there.
Yeah, it's been kind of a windy one. I would say I learned something at every step of my career. I got an itch to go work at a smaller company pretty early on. So BlackRock, was a lot of smart people and in many ways a great start to my professional career. But it was pretty clear early on that I wanted to be in a smaller, more dynamic environment. And so, I was kind of aching for more agency, feeling like I could contribute a little more. And so I then moved over to, at the time, a fintech startup, now a public company called Affirm. It wasn't necessarily the industry fit I was looking for, but it was a pretty natural extension from what I was doing at BlackRock and an easy jump into a younger company. And I think the biggest learning I took away from there is seeing firsthand how a small, young, scrappy company can really reshape an industry under great leadership. And I had some really shining examples of that in Max Levchin, the former PayPal founder, Michael Linford, who was the CFO at the time that I worked under. But that obsession with climate and energy had kind of always been percolating in the background. And I was really interested in commercializing new technology, commercializing new hardware, and specifically doing it in the climate space and having an impact on that problem. So that really came to a head in 2019 or so. I decided I had to kind of make a career out of that and cold emailed one of the co-founders of Forum Energy, Ted Wiley, eventually twisted their arm into hiring me onto their business team. Ended up working with them for a little shy of 2 years. And again, I think there got some great examples of what really good leadership what looks like with Ted and Matteo Jaramillo, the CEO, as well as some domain specific knowledge and I think a really high level view of what commercializing a new technology looks like at a cool inflection point for the company. So I joined, I think, when there were about 50, 60 people, almost entirely on R&D and engineering. And by the time I left, there were 400 or so. So that was a great experience. But again, I think the stage and the desire for agency and 0 to 1 problems kind of kept clawing at me. And I really wanted to branch out and do something that was a little bit earlier. And just kind of by luck, actually ran into my co-founder when I was living in Boston and was immediately impressed by what he was doing. What had become a little bit familiar with the problem of eFuels from my time at Forum and a couple of other experiences at the time. And I think was just immediately taken by him and the idea, the technology he was developing, and started working together part-time for a few months and immediately had a rapport and decided to make it a full-time thing.
How exactly do you go from kind of bumping into somebody with amazing technology and then actually going to work with them as a commercial person? I think there's plenty of people out there who want to be that, commercial mind that goes with the tech mind. And from what I've heard, the stereotype is always that, if you're a technical person and you went to Stanford or something, like you got all those business guys coming over your shoulder asking like, hey, can I build a startup with you?
Yeah, I think it's really important that you understand the technology as the CEO. And I think my co-founder Bronco would say that I very much fit that bill. But it's really important that you don't view it as two silos and really treat it as a collaboration. There was a lot of luck involved. I mean, I had been looking into electrification of heavy industry from the perspective of could we find potential buyers for a long duration battery, whether that's in steel, cement, or e-fuels, but also from the perspective of CO2 utilization. I had done a bit of work with a VC investor on a thesis around CO2 utilization. So I had a bit of a background in the e-fuel space. And when that kind of helped us establish that rapport quickly because Bronco and I were able to establish that mutually beneficial relationship where I wasn't just a business guy trying to do a startup and looking for a tech. It was actually an area that I was quite familiar with and, could contribute some market knowledge and get up to speed on the tech quickly.
No, I mean, I'll note it as a lesson for any of those people who are in the commercial seat is like, don't just pursue a startup for startup's sake, right? Build your own thesis. And then if you find somebody who matches, then there's going to be that natural fit to go together because otherwise you're kind of, chasing down a broken incentive structure, right?
Yeah, it's absolutely true. And one thing I'll add there is that I had, a great example at Forum. I think they're the best in the business at this. And if you listen to the early history of Forum, they were actually out raising money, exploring long duration techs before they ever had a chemistry chosen, right? They were defining the design space, what the market looked like, and really thinking about not just how to commercialize a cool tech, but how to develop technology that was serving a market need and really deeply understand the systems view. And I think taking that into whatever you're doing is really important.
Yeah, no, that makes a lot of sense. What influences really kind of got you interested in clean technology in general? You mentioned a little bit about your parents working in oil and gas, but just kind of curious, like what led you down this path, do you think?
You know that feeling when you meet someone who shares your vision for the future? It just clicks, like two peas in a pod. Well, that's exactly how we felt when we met Goodwin, who we are proud to have as our sponsor.
Being the first major law firm to set up a climate-specific startup and venture practice makes them exactly the kind of partner we are excited to work with. They realize that there are a plethora of challenges to building climate tech startups, and that's why they have built an entire suite of resources for founders, investors, and entrepreneurs in the space. They even offer several tailored pricing methods. And guess what? It doesn't matter where you are listening to this. Goodwin is a global law firm that you can trust to be your partner through it all, from incorporation to exit. They've got you covered.
Go to goodwinlaw.com and tell them Clean Techie sent you to get exclusive access to startup resources. All right, back to the show.
Yeah, I think, the main thing was I've always been fascinated in science and engineering and the ability of science and engineering to improve human lives. I've always kind of gotten a kick out of hardware and kind of concrete problems. My college major, I switched back and forth a bunch of times from more of the hard applied sciences to pure math and back and forth, and ultimately realized that I had a lot more of a passion for applied science and engineering over kind of the pure theoretical, but generally have always had a big attraction to hard scientific problems. And so the ability to combine that with, what I was viewing as one of the most important challenges and most important problems facing humanity, that just so happened to be also kind of what my parents were doing. It was kind of a nice nexus of things that I was interested in and had a connection to.
Yeah, I find it fascinating, the evolution, especially of technical people who are really just interested in engineering problems, kind of gravitating towards the clean tech sector. And I don't think it's always because they were motivated by the climate change dilemma. It's oftentimes just because of technology. And it just is fascinating to me to watch, like we're seeing in America right now, a lot of people still disinterested in this new technology, thinking it's just, as the conservatives like to call it, a green new scam,
Yeah.
as they refer to it. It's kind of a funny name, you got to admit, but the whole point is that people don't recognize that it's actually just the new technology, right? Like we've always been in favor of new technology, especially as America, like, and as innovators. So it'll be interesting to watch, over the next 10 years as the general public realizes what's really going on.
Yeah, and very much agree. And I think for me personally, and for a lot of people that I know in the space, it's very much a combination of both. Yes, we care about the problem, but equally importantly, sometimes more importantly, it's really fun work. It's we're reshaping an industry, one of the biggest industries in the world that touches every human being out there. And so many of the things we do in ways that we don't understand is being completely reshaped in a way that is exciting and multidisciplinary. And there are problems across electrical engineering and mechanical engineering and physics and chemistry and every other kind of cool discipline that you can think of. There's a problem to solve and an opportunity, with potentially big financial outcomes awaiting at the other end. So, we're driven by all those things at once. And I think that's what makes this industry, this sector, so exciting to work in.
You mentioned that during your time at a firm that you saw how new technology with good leadership could reshape an industry. Can you talk a little bit about the lessons that you learned from the time working with that leadership team, and what were the core things that you've taken forward into how you're building Lydian?
Yeah, I think, it starts with a belief that you can have an impact in an industry that's dominated by incumbents that are much better capitalized and much more experienced. Because I think there's a famous saying, which I'm going to mess up, but it goes something like, nobody has ever accomplished anything that they didn't initially think was possible, right? So that's the first step, is just having the conviction to know that a small team can have an impact and can approach a problem and change it and solve it in a way that even a large company isn't able to. And I think it's really that generalism. I would actually probably stop there. That's the biggest thing that I took away from a firm, is watching a team have that conviction and then relentlessly execute for years in a way that has now led to a great outcome.
Mm-hmm. Yeah, and don't let the haters shut you down, right?
Yeah, exactly.
Very good. So let's talk more about Lydian's technology. Can you just explain to me like I'm five, how does the technology work? And we'll go deeper in from there. Hey founders, if you're hiring, I've got a special offer for you. For those of you who do not know, to pay the bills, I run a search firm called Earth Tech Talent. That's Earth with no A. We specialize in placing top sales and engineering talent at early stage clean tech startups in the United States. And we do it for way, way less than traditional search firms. I've actually been working as a recruiter for over 5 years in clean tech and have made over 70 placements, from the CTO of IPA Power, a Blackstone-backed energy developer, to most of the founding team at ChargeScape, a managed charging software joint venture between Honda, Ford, BMW, and Nissan. Early stage clean tech startups can't afford to not have the right talent, but they also cannot afford to use a traditional search firm for their recruiting needs. That's where we can help. We charge as low as 12% of first year base salary, and this is compared to the typical 20 to 30% that most firms charge. So you can get an expert in the space at a price that does not break the bank. If you'd like to learn more, check out our website, earthtechtalent.com. That's, again, Earth with no A. And we really value transparency, so our pricing is publicly available on the website. If you're looking for support, book a call today. My calendar link is in the description, and be sure to reference this ad for $1,000 off of your first search. All right, back to the show.
The technology started with a catalyst innovation that was invented by my co-founder, Bronco. And we've since kind of designed a reactor and a process around that to try to unlock the benefits of what that catalyst innovation allows. And so I think the two problems really facing eFuels today are energy intensity and capital intensity. That's obvious, right? It's CapEx and OpEx. The energy intensity is really limited by thermodynamics. You're not going to get around it. You might improve it somewhat, but if you're trying to make a fuel out of a feedstock that has no embodied energy, you're going to have to put in a lot of energy. The only thing you can do there is make sure you're using the cheapest energy available. And what that means is that we need to figure out how to make the plant load follow, how to make sure that we can monetize the cheapest electrons out there, which today are wind and solar, and increasingly are wind and solar. So that was something that catalyst innovation, it was very clear from the start that it would be very well suited for load following. And from there, we had to solve the capital intensity problem, and particularly in the context of where you're trying to operate something intermittently and get a fairly low utilization rate. It becomes ever more important that your capital is cheap, so you're okay running it at a lower utilization rate. And so there, it's just been one engineering challenge after another, but starting from first principles of, again, doing that system level modeling and figuring out where does the plant need to be to deliver a commodity which is at parity or close to at parity with the underlying commodity of fossil kerosene or jet. And we have pulled a lot of levers to get there. I would say the two, it ultimately comes down to process intensification. So your major equipment like your electrolyzers and your chemical reactors are a huge component of your capital cost. How can you make them as small as possible, but also made of cheap materials, and mass manufactured so that you can make a lot of them and bring the cost down? And then there's process simplicity. But there are going to be a lot of components like compressors and tanks and land and buildings, which you have virtually no ability to bring the cost down of. The only thing you can do is eliminate them as much as possible. And that is something you can only do if you can squeeze a lot of performance out of the major equipment, the parts that you do own. But to the extent that you can't eliminate them, you have to make them big. You have to make them standardized. You have to limit the non-recurring engineering. And so there's a lot of work underpinning all of this, but ultimately it's combining a first principles approach to technology design and leveraging the benefits of that catalyst that we originally invented.
Okay, got it. So we're going to back up a little bit, and then let's talk about how the tech works. So is it like, give us a basic explanation of what goes in, how do you change it, and what comes out, and then like who's the end user, or at least the conceptualized end user?
Yeah, absolutely. So our inputs into our plant are carbon dioxide and water, and we split the water into hydrogen. We do that with off-the-shelf technology from electrolyzer manufacturers. We don't have an innovation there. And then we take that CO2 and hydrogen and we convert that in a two-step process to a hydrocarbon fuel. And we are targeting specifically the jet fuel range, which tends to be about 8 to 16 carbon atoms, give or take. And that fuel that we end up with is a drop-in alternative for the airplanes that we have today. So it really is almost molecularly identical and close enough that you can use it in an airplane as a drop-in fuel.
Okay. And then, so going back to what you said previously, you're talking about doing this in a way that is, what do you say, like you drop off a container and this stuff is there. You don't have to build a huge plant. It's more flexible that way. Is that accurate?
I mean, our plants will need to be fairly sizable in order to have good unit economics, but there is kind of an art to designing the major equipment in a way that can be quickly installed and that can be numbered up instead of scaled vertically.
Okay.
And that allows us to eliminate risk early on, right? So we'll actually do a demonstration project in the next 2 years that we expect to be the largest kind of individual reactor that we ever build. And that timeline is something that is not feasible for a lot of new technologies if they're kind of just scaling vertically.
And then, so is there a component here that is you have a lot more location flexibility, which allows you to get closer to cheap energy? Is that accurate?
Yeah, I think that's a great way to put it. I think locational flexibility is ultimately going to be constrained by those inputs, so water and CO2. At the limit, we might be able to pull CO2 out of the air. Again, that's not a piece of the technology that we own, but a lot of people are working on that and continue to make improvements. In the near term, we'll get CO2 from an industrial point source, and there are a lot of those around the world, so we can co-locate or we can locate very close to one and deliver that CO2 ideally via pipeline, but potentially via other means as well. So being able to operate intermittently does allow a lot of locational flexibility, and being able to deploy the plant in a standardized module with limited recurring engineering allows us to do that really quickly. So yeah, there are a lot of benefits to the siting as well.
Climate tech founders are taking on a huge challenge. Not only do they need to know how to build a startup, but they also need to deal with hardware, have a strong handle on climate policy, know how to fundraise from diverse investor types. It's a lot.
That's why we made Clean Techies, the #1 podcast for climate tech entrepreneurs. In addition to our jobs, we devote 20 hours a week to producing this podcast for you. This way you can learn from the people who have walked the path before you, learn from their mistakes, and gain insights on navigating this complex journey. If this mission resonates with you, we are asking for your help. It takes a lot of effort and it's not free.
If you are already a subscriber and want to help, start supporting us today by going to Substack and clicking Upgrade to Paid. Thanks for helping all the climate tech entrepreneurs like you. Yeah. So just to make sure we tap into this a little bit more, you said something. You said two different things. So you said load follow and then intermittent usage. So can you explain to people what that means when you say that you don't have to, is it basically you don't have to always be on like other plants would be?
That's exactly right. The conventional way that a chemical plant is designed is to run pretty much at full capacity. I mean, they might have some operational flexibility, but typically you have an energetic feedstock coming in. That could be a crude oil or a methane or something else, a coal. And, the challenge has historically been, let's make this plant complex and squeeze the most yield as possible out of this feedstock, which tends to dominate the overall cost. So they're long-lived assets, they're built to last for 50 years or more, and they're designed to operate continuously. What we do is, think about at a high level, really our problem is trying to replace a very cheap commodity, crude oil, with a commodity that historically has been more expensive, electrons. And that's ultimately what we're doing. And we're also adding CapEx for that conversion step. So we need to make sure the electrons we're using are as cheap as possible, and really solving that challenge is the only way that we can get anywhere close to the underlying commodity price. And again, today, wind and solar are by far the cheapest electrons we have and have ever had. They're not available around the clock. They'll never be available around the clock. And we can store them in batteries, but that adds cost, which, a lot of different applications can bear that cost. Computing can bear that cost, heating and cooling, vehicle charging. Making a commodity hydrocarbon can't bear that cost. You really need to go to those very, very cheap electrons.
Got it. So you're able to take advantage of when there's excess energy on the grid. It's very cheap, and they need somewhere to put it anyways. So you can build a plant there. Does that mean? I mean, maybe not now, but in the future, you plan to partner with the energy developers directly, who may need to figure out a way to get rid of the excess energy? Because I know that there's been Bitcoin mining operations or data center operations that have done kind of something similar to absorb the excess load.
Yeah, those are conversations that we're having, absolutely. And we're able to do that in a few different ways. I mean, we can co-locate with a renewable energy project and take a portion of their load in a flexible way that allows them to sell a different profile that's more valuable back to the grid. We can procure that power virtually and operate in a way that adds value to the grid operator itself, not just to a single renewable energy developer. But yeah, that's absolutely part of the strategy. And I think Bitcoin mining has been an early model for this. There are other models. There a couple of aluminum smelters, one in New Zealand that is operating this way. So yeah, that's very much a part of how we'll deploy.
Interesting. And so this is this the kind of the key difference that you guys have versus other companies who have tried to do something like this?
I think it's definitely one of the key differences. And we always say that when you're trying to operate in this way, there is a technical component. So you need to make the plant technically capable of load following. And again, that's a non-trivial thing to do for a chemical process. Upsets can deactivate catalysts, they can cause fouling of major equipment, and just generally other problems that most chemical plants don't want to deal with. There's a lot of engineering and IP that goes into unlocking that technical capability, but there's also an economic aspect there where you have to realize that even if your plant is capable of operating flexibly, if you make it too expensive, you're not going to want to do that because the kind of the economic signal of the equation, you're trying to pay it back. You're trying to get capital amortization. It ultimately starts to dominate your cost equation more than the OpEx in a way that would make you more willing to pay for more expensive electricity. And that's what we see in computing and data centers, right? Flexibility is not that hard for certain computing applications, Bitcoin being a great example. But the value, the so-called watt-bit spread, typically, and the cost of those plants, by the way, data centers are billions of dollars, dictates that they tend to prefer to run continuously.
So being from a finance background, does the model you have where you're not going to be running continuously, but because you are, it's cheaper to produce these things, these plants, it still will pencil out from a private equity perspective, eventually coming in once the tech is proven, because that's the dream that everybody's trying to get to, is we need to get reliable enough income so that private equity can dump, billions of dollars in rather than, several $100 million in here and there.
Yep. And there are many things that we have to creatively do to make sure that the model is financeable in that way. And the reliability of the output and the cash flow streams is one of them. But the short answer is yes. And in fact, our plants are designed to operate not just in a way that's profitable with intermittency, but actually to be optimally profitable with intermittent operation.
I see.
Meaning they're cheap enough that we actually prefer to turn down in many hours of the year and avoid the high priced hours.
Yeah. Okay. And then, so how do you make money? Like, is the objective, maybe you're working on the financial model still, because some people have multiple options, but is the objective just, hey, we're going to be a fuel producer and we're going to sell to the airlines? Are you partnering with other people? Like, what's your guys' model currently?
Yeah, there are multiple options for us as well. And we're going down the route of both. Really two high-level ways we can make money. One is to develop and operate our own projects and to sell fuel. And we can sell fuel directly to the airlines. We can do it through an intermediate like a fuel supplier. And then the second model is to sell technology. So we can either license a technology package, we can be an OEM and actually sell the equipment to renewable energy developers who are interested in developing e-fuel projects. We will kind of lean toward the first model in the early days as we seek to prove out the technology and kind of, focus on owning and operating the first of a kind plant. And then we may shift over time into more of a hybrid model.
Because it's common that if you're going to do a licensing model, you have to be able to provide certain guarantees, which only comes if you've operated for a period of time. Is that correct?
Yeah, that's exactly right. Typically, there's often no way around having to prove out the first instantiation of the product on your own with your own capital, underwriting your own risk. There are also benefits to doing that, right? We can learn how the system operates, what works, what doesn't, and perfect the product over time before we go out to the market and try to license it.
Yeah. So another big thing I'm trying to understand is what existing value chains or supply chains do you plug into? Because oftentimes, if you have to rebuild the entire thing when you're trying to build a new technology, it's difficult. But if there's kind of certain behaviors or existing infrastructure, you can just make an innovation that's going to, not piss too many people off and benefit your customers, and you can pop in there. Is that what you guys have done? Because it sounds like a lot of your hardware you said is off the shelf, and it sounds like there's probably a distribution kind of network. Like, tell us more about that.
Yeah. So on the product side, the goal of making a drop-in commodity is something that I've always been kind of really interested in. I've heard some people describe this as, if you build it, they will come risk. So if you make a jet fuel, you've got a buyer for it. It can go in existing pipelines. It can go in existing airplanes. You don't have to worry about setting up those supply chains from scratch. On the actual build and fabrication of our technology, there are some supply chains that we are going to have to spin up and manufacture our own parts. There are specialized materials and technologies. Ultimately, we've solved for things that have a really low cost entitlement. So they're based on non-precious materials, things that we have a lot of, but that doesn't necessarily mean that we're using things that are off the shelf or mass manufactured today. We try to do that wherever possible, but ultimately it's a new technology, and a lot of the things that we're doing are completely new, and we will have to spin up manufacturing lines to make that a reality at scale.
Mm-hmm. Yeah, no, that's helpful. So, I might be putting words in your mouth here, but I'm just trying to think through the logical conclusion of if this works, right? If you guys continue to build this and we see the continued trend of, this idea of energy abundance, right? If we can build lots of renewables, hypothetically, we have, unlimited electricity to produce things like, this fuel. I mean, is it safe to say that, just if we, for the average person who may not quite get this, like you look forward in however many years and you can see that we're able to produce the fuels that we use to fly around the world out of just air and water, and we have all this extra electricity just everywhere. And so even flying, we don't have to feel guilty about it because the CO2 that's going to come out is basically coming right back into the value chain. Is that like a fair assessment of what you're hoping to achieve it with the vision and impact here?
Yeah, that's exactly right. And we think it'll be part of the solution. There is space for others. Eventually, short haul aircraft, regional aircraft might go to batteries. Over time, that might even extend to medium. It's very hard to envision that going to long haul aircraft anytime in the next 50 years, probably longer, but you never know. And you have biofuels as another solution, and biofuels have their drawbacks, but in certain contexts, they can be pretty cost effective, and they're made out of a non-anthropogenic, non-fossil CO2 source or carbon source, I should say, that does have some climate benefits. So combine those pieces all together. And yeah, the vision here is we need to stop global warming. That means we need to have no kind of net flux of fossil CO2 being increased in the atmosphere. And yeah, so the vision here is to really penetrate all the way into aviation and make sure that we can do that in a sustainable way.
Yeah, I mean, this is got the hair on my arm standing up. It's just it's an amazing vision. I think if anybody was a little bit down on things happening in climate right now, don't be, because you can go work for Joe and you're going to change the world. So I'm
Yeah.
sure you guys will be hiring in the near future. I don't know when this is coming out exactly, but definitely take a look at their careers page.
Yeah, take a look at our careers page. And I'll also just add one more point that we've got a lot of folks on our team that are, I'd say, av geeks, like really interested in the power of aviation to connect people, to drive new industry, to drive new economy. And I think it's really important to bring up that still today, despite the fairly sizable impact that aviation has on the climate, a very small portion of the population is actually flying and can afford to fly today. And that's part of our mission, is to really make sure that we have a sustainable solution out there to not just to decarbonize the aviation that we have today, but to expand access to that aviation over time.
Yeah, I think this. I didn't plan to talk about this, but I think it's interesting in the people who are kind of like accelerate everything versus we have to slow down, we have to reduce our usage of everything. I don't think that, first of all, we're going to cut back on everything. Like, yes, I understand it's needed, but it's not extremely exciting. Versus when you're saying, hey, we've got all this abundance, especially in these more developed countries, wealthier countries, we should be focused on finding ways to get to this point of total abundance where I don't care if I leave my lights on because electricity is so cheap and the sun, well, not in Wisconsin, but the sun's always shining somewhere, right? And I don't have to worry about it. And then we can, like you said, eventually massively reduce the cost of flying, hypothetically, right? And I don't know if you have any takes on this kind of accelerationist movement, but I know that a lot of climate people have kind of debated whether or not this is the right thing. But it feels like you're in the camp of, if it weren't working on, having this abundance future, we wouldn't be able to, we wouldn't be funding these things.
Yeah, I mean, thinking about a future without abundance is not a very nice future to think about. And I think many times people underestimate, I think, the negative impacts that would come with not having that abundance, and positive parts of their lives that they may not realize come from having that abundance and having had that abundance historically provided by fossil fuels is the uncomfortable truth that we have to contend with. Now, everything has to be done within limits, right? There is a real economic cost to climate change and to the world warming, and we know that. And there's a pretty big range of uncertainty on what the quote unquote social cost of carbon is, but it's very clear that it's real, that it's not priced in, and that the more CO2 we emit, that's economic cost down the road. And so we have to do things. We have to seek abundance and accelerate, but we have to realize that there is a cost to doing that. And if we don't address it, it's going to be more expensive the longer we wait.
Mm-hmm. Yeah, absolutely. I appreciate that thought. So recently, you guys also had a successful pilot project. I would like to know a little bit more about this because my understanding from a little bit of prep on this is that you have successfully done this in 3 years. I think from tech to pilot. So can you just talk about how you do that? Because that is, if that's the right numbers, that is wild, right? Nobody does things that fast.
Yeah, 3 years. It's about 3 years from when Bronco started working on the idea, and at the time he was still kind of doing some other work on the side, and this was a bit of a side project. And it's really more like 2 years and 3 months from when we first got lab space and made our first hire and started working on this in earnest. So I think number one kind of factor there has been Bronco and the team and just the amazing pace and intelligence and drive that they move with. But also on, I think, the design from first principles that we talked about, realizing that the system had to be really simple and really cheap. We realized very early on that you don't start with this huge complex system with bells and whistles and just wait for it to get better over time. It's not going to work out that way. In fact, if anything, it goes the other direction. Complexity is forced on you as you scale up and uncover new problems. So if you don't begin with something that is incredibly simple, you really have very little chance of scaling up and commercializing. And I think that's the second point that allowed us to do this was we designed for radical simplicity and low cost from the start. And that allowed us to deploy pretty cheaply and pretty quickly at a scale that has taken other folks a lot longer.
No, that's definitely got to be a clipped moment right there. That's that's something all founders who are trying to build deep tech or hard tech of any sort should really, really think deeply about. No pun intended. Okay, so let's shift into trends a little bit. So first thing I want to, I guess, talk about is broadly speaking, how do you view the e-fuel space? Obviously, you guys are building in it, so I'm assuming you're somewhat bullish. But what is it like right now in the atmosphere out there? Are people still looking to pay a premium for this? Because I had understanding that there was a lot of demand, but not enough supply. So just tell us more about what's going on there.
I think the biggest learning that I've taken away from Clean Tech 1.0 and Cylindra in particular is the cure for high prices is high prices, right? There is a voluntary credit market for sustainable fuel production. It's pretty early. There are a couple of groups here in the US working on that. I think the pilot demonstration on the technology side is a big one, and it really serves as the first major proof point for...
Hey guys, this is the end of the free version of the episode, and if you would like to avoid hearing my homemade sound effects in the future, become a paid subscriber to get the full show each week. You can do that by going to cleantechies.substack.com/subscribe and pick a tier that works for you. It's $10 a month or $80 a year, so head on over. And if you are interested in becoming a paid subscriber, I wouldn't sit around too long because on May 1st, the annual subscription cost is going to go up to $100 a year. All right, see you on the other side.